I'm standing out here in some degraded thicket outside Steytlerville, and one of the things that I've been thinking about quite a bit since my time in the field with Professor Cathy Clarke, the soil scientist from Stellenbosch, is just the amount of soil that's been lost on this landscape. And yeah, this is a great indication of how much soil has been lost. These are exposed roots of this Papia capensis, premworm, and this tree is probably 200 to 300 years old, if not older. We've got radiocarbon dates of trees in a very similar size to this, also in an arid region, a little bit to the east of where I am now, which indicates 300 to 400 years old. So these could, I'm kind of guessing on the low side on 200 to 300 years. So when this plant was established and already established and very large, you can see where the roots were. And the soil probably came up to that notch there. And so we've lost 20 centimeters, 30 centimeters of soil here. And every tree that you go to has the exact same story. And I'm not in a donga. I'm not where water would normally kind of flow and channel here. This is just on barely a slope. And I'll go to some flat areas because you see the exact same thing in the flat areas. So I reckon around about there would have been the soil profile previously. And yeah, so we've lost all of that. Now that would be the A horizon that Cathy was talking about when she was comparing what was going on underneath the speckboom and out in the open. And effectively, what I'm walking through now should have been a closed canopy, succulent dominated dwarf forest. I shouldn't be able to walk through it. I should be absolutely struggling, having to find the odd animal path to make my way through. But when all of that, and that vegetation built up a major A horizon, but when all of that got cleared, driven by domestic herbivores, goats, and primarily goats, and then also some sheep at a later stage, then this A horizon just washed away. And that A horizon was very loose, unconsolidated. This is probably the B horizon here. So the water goes down to the B horizon and then just washes down the landscape. And so you lose that A horizon very quickly. See, here's another example. You can see the exposed roots. Again, there's a side root there. I'd estimate the soils are probably about that level. So again, about 20 centimeters there. And this really isn't a very steep slope. Let's go and have a look at another one. You can see there were some roots that went off over there that have broken off. Yeah, see these roots, that root over there should be at least 10 centimeters under the ground, not spreading like that. So I think that's, again, has had a little bit of soil loss. Maybe this one's only 10 centimeters. One of the things that's an interesting impact after the drought is that you can see that there's a lot more mealybug infestations on these leaves, something I don't really see all that often, but I see just about on every tree now. is this mealybug infestation with ants gardening with the mealybugs. And it's got to do with, I'm sure, got to do with these trees still experiencing drought stress from the drought that kind of ended 2 years ago. I'm just going to carry on wandering and have a look at what the bases of the next trees over here look like, and then I'll leave it at that. Yeah, look at that. All of these exposed roots. Completely not normal for this species. Papia. Soil should be there. We've actually lost almost 50 centimeters here from the base to the top there. Absolutely wild. And so when we're planting speckboom into these landscapes for restoration, the whole aim is to rebuild that A horizon in the soil. There's actually a section I'm in has been replanted for restoration purposes. You can see there's one over there. That's a speckboom. Another one over there. Another over there. So I mean, these have just been planted in the last year or so. And the whole idea is that we're relying on these little chaps to grow into very big bushes that sprawl along the ground and trap the leaf litter, trap the soil, and then rebuild the air horizon. And the reason why there was probably the reason why that air horizon was there in the first place was most likely driven by the presence of speckboom in this landscape, because of the way that it grows in this kind of sprawling form along the ground as well as growing upwards, and then it captures all of the nutrients. You've seen that in my other videos as well. But when that got stripped out along with the other members of the community, then these were the last remnants that could be above the browse line. You see they all look like they've been manicured. That's the browse line for the herbivores. These plants should go all the way down to the ground. They shouldn't look like trees. It should look like bushes. But effectively everything in that band just got mined out. All the vegetation got mined out by domestic herbivores. But there is some hope with restoration and returning this landscape. Maybe in 100 years we'll rebuild this air horizon. Probably take a bit longer. But yeah, this restoration is putting these speckies in. It's probably the only way that we're ever going to rebuild this air horizon. Leave you with some money shots of severely degraded thicket. You can see there's a fence line contrast up there. Oh, don't focus. See over there. That's been degraded this side, and that's a succulent dwarf forest on the other side. The entire hill slope should have been covered with succulent thicket. And you can just imagine we've lost all the air horizon of that entire landscape. Across all of this, we've lost 20 to 40, maybe 50 centimeters of topsoil. That's a lot of topsoil. And it's affected the productivity of this landscape as well, because now we're down to just this really terrible B horizon, not the nutrient-rich A horizon. Okay, leaving it there.